Okay, Science 10, you should have completed that ionic charges sheet. This is the next book that I want you to look at, dealing with ionic compounds. Now, ionic compounds consist of a metal or metals bonded with non-metal or non-metals. This particular assignment, we'll just simply looking at one metal bonded with one non-metal. Okay, so what you should have seen in that previous assignment is that certain groups have similar properties. So, for example, this first group, positive 1. Second group, positive 2. Third group, positive 3. Then over here, 3 negative, 2 negative, 1 negative. And then these groups didn't need to gain or lose electrons. They're relatively stable. And then we have a few throughout here which have more than one option, which we'll have to look at. Okay? So we take a look at what happens here. I'll talk about this diagram in a second here. What I want to look at is names. Now, the names of atoms when they lose electrons to become positive, the name essentially stays the same. So right over here, name of positive ions is the same as the atom name. So I'll just type that in right there. The name doesn't change. So lithium ion is the same thing as lithium, just simply referred to as lithium. However, when we go over here, this side, when atoms gain electrons to become negatively charged, the name changes. So name of negative ions, adopt the "ide" ending. So if we look over here at some of them, fluorine, when it becomes the ion form, it's fluoride. Chlorine becomes chloride. Bromine becomes bromide. Iodide, oxide, sulfide, nitride, phosphide. So that's one thing to remember. You kind of drop the INE, or in some cases in oxygen, you drop off the YGEN and adopt the "ide." Whatever seems to sound all right. Nitrogen, nitride. Phosphorus, phos, and this whole forest part is dropped to become phosphide. Okay? And of course what happens here is that they come together due to positive and negative attraction. So that's kind of what an ionic bond is. A bond formed between the positive and negative attraction between metals and non-metals. Okay? Another thing to note there is that the overall charge needs to balance out and become 0. Oh, I kind of wrote a bit too big here. Let's see here if I can shorten that up a little bit. There we go. So that's an important thing to note over here. So for example, if you look over here, what happens between aluminum and chloride? Aluminum is positive 3. Chloride is negative 1. Now, we just can't have one aluminum attracted to one chloride because that will not balance out. The one negative of chloride would balance with one of the positives of aluminum, and that would give me 2 positives left over. So, as you can see here, it's kind of like the lowest common multiple in math. We would have to have 3 chlorides. Each one is negative 1. 3 chlorides would have 3 negatives. 1 aluminum is 3 positives. So then that would balance out. So the formula for aluminum chloride would be AlCl, but we'd have to show that we actually have 3 chlorides there. And we do that by just writing a lower number 3 there, which is referred to as a subscript. So formulas don't have these charges here. These charges here are just simply there to help you figure out how many of each you need to be balanced out. 1 aluminum, 3 chlorides. We would call that aluminum chloride. And that's basically how it works. So if we look at the next page, I have some examples here. Calcium and bromide. So we're going to have to look back at the previous table to figure out what the charge of each of these are. So calcium, 2 positive, bromide, -1. Okay, so we have calcium. I think I wrote that off the page here. I'll just bring it in. Calcium and bromide. Let's see if I can bring that in here. Calcium and bromide. And of course, all my things are going off the page here. Let's see if I can fix that. All right, so calcium is 2 positive. Bromide is 1 negative. Oops, moved everything out of the way there. Okay, so that. So we can see here that this isn't going to work. Each calcium's worth 2 positive, each bromide's worth -1. So if I had another bromide, that would make things work out. And again, I kept grabbing the wrong thing here. To work with here. So that would balance out. If I had 2 bromides, that would completely balance off what I have here. 2 positives, 2 negatives, that balances out. So overall, what do I have here? The formula for calcium bromide, I have 1 calcium and 2 bromides. So I write that as a subscript 2, CaBr2. Okay, that's basically how it works. Over here, copper. Now you may notice that copper here has more than one option. I think I have, oh yeah, here it is right here. So copper is in the middle group. It's in the middle area, and those middle areas have more than one option. So if I look here, copper can be +1 or +2. So it's nice in this case, I actually tell you what it is. It's Roman numeral 1, which means it's the version of copper that is +1. It's this version right here. So copper 1. Sulfide. If I look for sulfide, there it is right there, S2 minus. So S2 minus. Let's label that down, and my number 2. So to show that it's a raised 2 minus there. So we can see that's not going to work. +1, 2 negative. So what am I short of? I'm short of copper. So if I have a second copper, that will balance out. 2 positives, 2 negatives. So that tells us that the formula for copper 1 sulfide is Cu2S. I need 2 coppers for every 1 sulfide. Okay, good. What I do is I think I'm going to split this video into 2 parts. So I'm going to get you to try the next 2 and then queue up the next video, part 2, and then you'll be able to see if you did it right. Okay, we'll see you in a bit.